Susan is known to many people in this room because she has been institutionalized in various places in Ontario and Vancouver. But the more important thing to say is that she is now the Deputy Director of the Center for Forensic Architecture at Goldsmiths in London. She worked very closely with A.L. Weissman, who will be Skyping in this afternoon. A.L. tells me not once, not twice, but 3 times that Susan is indispensable to the work that the Center for Forensic Architecture is doing. She is a pivot around many things in the forensic and nuclear world. It's terrific to have her here. Susan, welcome.
Well, thank you so much. And yes, I need to. Is there a little clip? Yes. And that's on. So yes, thank you so much. And it is indeed wonderful to have such extraordinary colleagues here in the event and in the audience, but also very, very close friends and people I've known for a long time at many different kind of points in my life. And John O'Brien, certainly you rank there as one of the kind of enduring intellectual supporters of my my work, and a kind of long friendship that goes back to when I first arrived in Vancouver to embark upon my undergraduate studies at Simon Fraser University. Claudette, I also want to thank you. I know what it's like to organize events with sort of multiple strands and all the kind of logistics that go along with it. So you've done an extraordinary job, so thank you very much. Now, I work in the Center for Research Architecture, and I was working on forensic architecture, was a European Research Council project that continues. And that project, I have to say, continues to be kind of influential in my own thinking, certainly, and it's a project in which we used, if you will, certain kind of architectural intelligence to investigate complex violations of human rights and to produce different forms of evidence that's made it into various kind of domains, including kind of juridical domains. And immersed in that project, I'm also in the process of trying to finish a book project called Material Witness, Forensic Media and the Production of Evidence. And it really tries to track various material artifacts through the kind of institutional context in which they gain their kind of traction and around which stakeholders sort of gather and disclose, if you will, their kind of politics. And consequently, because I'm so much in that sort of world of evidence at this very moment, you'll notice that I've actually changed my presentation somewhat. I thought I was going to talk about the Gamma camera that Toshiba developed, the portable Gamma camera to visualize radiation at Fukushima, but I thought I would do something a little more granular, if you will, and I say that because I think I can only do that because of the context in which has already been set here. The kind of extraordinary, I think, conceptual, political, epistemological frameworks that have been put in place by the various sort of speakers, so that I'm going to look at 3 particular events and then conclude by just raising some questions and comments. And my hope actually would be, if we have time, that maybe the conversation could be not so much about what I'm presenting, but maybe a continuation of some of the kinds of refrains that have come up through the various presentations. So if you bear with me, I will read, as is my style. So I'm calling this Trace Evidence and the Politics of the Remainder. So I'll begin with geology. In May 1972, a scientist working at the nuclear fuel reprocessing plant in France ran a series of standard tests on enriched uranium samples recovered from ore mined at Oklo in the Franceville Basin of Gabon in West Africa. The results of this routine analysis proved strangely perplexing and revealed a lower than expected level of the isotope uranium-235, the crucial atomic ingredient for sustaining a nuclear reaction. Uranium-235 is one of the three primary isotopes found in the Earth's natural uranium reserves, each of which is characterized by a different atomic mass, with U-238 comprising 99.28% of the planet's total uranium isotopes, followed by U-235 at 0.72% and infinitesimal amounts of U-234 on rare occasions. Now, despite the changing chemistry of the planet over more than 4 billion years, the ratio between these naturally occurring uranium isotopes is thought to be consistent throughout the geology of our solar system, whether they are found in the Earth's crust, in meteorites that have broken free of asteroids, or in pilfered moon rocks. Although U-235 atoms make up less than 1% of the total isotope count of uranium, the disproportionate results evinced by Oklo's ore, which disclosed a diminished mass of 0.6%, or half the anticipated levels, troubled a science built upon the singular constancy of a fixed ratio between U-238 and U-235 isotopes. The slight depletion in the amount of U-235, combined with the presence of an excess of certain fission products, was enough to convince French nuclear scientists working at the French Atomic Energy Commission that the rocky material carried trace evidence of a radical new state of matter. Quote, further analysis showed that ore from at least one part of the mine was far short on uranium-235. Some 200 kilograms appeared to be missing, enough to make half a dozen or so nuclear bombs, end quote. So where did the missing radioactive material go? All radiological isotopes, whether found in nature or artificially manufactured, emit radiation at various rates of decay. While several thousand have half-lives of less than an hour, there are 650 radionuclides that take more than an hour to decay, and some, such as the two that are found in the chemical tellurium, registering half-lives over an unimaginable stretch of 2.2 septillion years and 790 quintillion years, respectively. Fortunately, in its elemental crystalline form, tellurium is much more abundant in the universe than on Earth. However, with the case of uranium, the rate of radioactive decay varies between its three isotopes, such that U-235 decays at a much faster pace than its more ubiquitous companion U-238. Therefore, the only viable scientific explanation that could account for the reduced mass of the Oklo samples was that the original percentage of U-235 atoms must have been much higher at one point, somewhere in the range of 3%, in order to arrive at its present state and yield such anomalous readings. Given that today, a change in the natural ratio between U-235 and 238 atoms can only ever be artificially achieved by inducing a series of nuclear chain reactions, the French scientists who ran the tests in 1972 surmised that a nuclear reactor of some kind must therefore have existed at Oklo some 2 billion years ago. Indeed, the depleted atomic signature of the ore samples was astonishingly similar to the same percentages found in the spent fuel produced by the reactors of contemporary nuclear power plants. For the proportionate levels of radioactive decay to align themselves correctly with those observed in the enriched uranium extracted in Gabon, scientists would have to calculate backwards into the far distant past, to the time at which the Oklo deposits first formed, approximately 1.7 billion years ago, and started their slow energetic burn. The conditions of early Earth were, of course, dramatically different from those present today. allowing uranium grains trapped in rock to dissolve and achieve sufficient concentrations for sustaining a nuclear reaction. Through processes of weathering, gravitational sorting, and enrichment, uranium minerals would go critical in a unique oxygenated environment that no longer exists on Earth today. This is a quote from some of the physicists that were working in the French, or that have talked about this phenomena. So physicists confirmed that the basic idea that natural fission reactions were responsible for the depletion in uranium-235 at Oklo quite soon after the anomalous uranium was discovered. Let me repeat that. Physicians confirmed the basic idea that natural fission reactions were responsible for the depletion in uranium-235 at Oklo quite soon after the anomalous uranium was discovered. Indisputable proof came from an examination of the new lighter elements created when a heavy nucleus is broken in two. The abundance of these fission products proved so high that no other conclusions could be drawn. A nuclear chain reaction, very much like the one that Enrico Fermi and his colleagues famously demonstrated in 1942, had certainly taken place, all on its own and some 2 billion years before. Oops, pardon me, I should have had that up. Radiological evidence in the form of a geological proof, 200 missing kilograms of U-235 corroborated the propositional fiction forwarded by American theoretical physicist George W. Wetherill already in 1953 that self-sustaining nuclear reactors once raged across our planet. The discovery in West Africa some 20 years later would come to be known as the Oklo phenomena. Over time, 19 such ancient nuclear reactor zones were eventually found within the region, some revealing traces of even much larger reactor cores. The Oklo phenomena, as a radiological relic of the primordial time of early Earth, is surely the warning sign par excellence of the extreme temporality of our nuclear inheritance. Meteorology. Early Monday morning, on April 28, 1986, Cliff Robertson was about to begin his shift at the Forsmark Nuclear Power Station, having just finished breakfast in the coffee room. When he passed through the plant's radiation detector, he set off its alarm, signaling the dangerous presence of radioactive contamination. After repeated attempts to enter, the alarm's warnings were eventually silenced. Robinson hadn't yet been in the controlled area of the plant that day, so assumed that the alarm was faulty, needing some minor adjustments. Robinson was employed as a chemist at Forsmark, one of Sweden's largest nuclear power plants, located a couple of hours north of Stockholm on the country's east coast. His job was to monitor radioactivity throughout the power station. When he completed his rounds that morning, he returned to see a growing queue of workers waiting to pass the detector. Each time the alarm would emit its seemingly temperamental caution. No one could get through because the alarm kept going off. Realizing that something much more serious might be happening, Robinson grabbed a shoe worn by one of the waiting workers and placed it on the germanium detector in the lab. And he says, "Then I saw a sight that I will never forget. The shoe was highly contaminated. I could see the spectrum rising up from it very quickly, and it was just amazing because there were so many radioactive elements there that we normally don't see in the cooling water at Forsmark." After alerting his superiors, Robinson was asked to inspect the plant's chimneys to determine whether a radiation leak was coming from Forsmark. Oh, actually, he says something. I edited this out accidentally. So when Robinson notices these radioactive contaminants coming from, and he notices that they don't seem to be similar to the kind that are produced at Forsmark, he also says that he remembered vaguely that he had some idea that perhaps a nuclear bomb had been exploded somewhere. So by 11 a.m., further alarms sounded and an evacuation order for the entire plant. Only key personnel involved in safety procedures remained behind. Robinson was one of those who stayed to monitor for radioactivity. Nothing indicated any malfunction or problem at Forsmark. It was just that the surroundings were heavily contaminated. Testing of all 3 of the reactor blocks came back clean, suggesting that the source of the leak must indeed be coming from outside the plant itself. When the Swedish Radiation Safety Authority received notification from Forsmark later that morning, reporting unusually high levels of radiation, despite no evidence of any breakdown at the plant, concerns that an atmospheric release of radioactive isotopes had taken place somewhere else were immediately raised, including the possibility of the detonation of a nuclear bomb. Soon other Swedish plants were also reporting extremely high levels of radiation. Baffled, the authority began plotting reports of contamination in Sweden, reactor locations in the region, and charting wind patterns on a map. Soon several Soviet nuclear power plants, including Chernobyl, started to emerge as a probable source. Indeed, initial speculation pointed to a Russian plant close to the Swedish border, given Chernobyl's considerable distance from Forsmark. The scale of the accident would have to have been massive if radioactive isotopes originating from as far away as the Ukraine were to have migrated northwest to produce the levels of contamination reported in Scandinavia. Eventually, direct evidence in the form of a radiological fingerprint, cesium-137, would corroborate the growing suspicion that contamination discovered at Forsmark could only have come from outside Sweden. Cesium-137 is a radioactive isotope that results from human activities, either that of a nuclear reactor or the detonation of an atomic bomb. It occurs spontaneously when much heavier elements such as uranium and plutonium absorb neutrons and undergo fission. Cesium-137 has a half-life of 30.17 years and emits beta particles and gamma rays when it decays to barium-137, which then decays to non-radioactive barium. Chemical testing of Forsmark revealed the presence of a radioactive isotope not native to those produced by its reactor, nor indeed by any of Sweden's other operational power plants. Despite the urgency of the situation, communiques with Moscow resulted in an unequivocal no when Swedish diplomats inquired as to whether a nuclear accident might have taken place anywhere on its soil. Only when Sweden threatened to file an official alert with the International Atomic Energy Authority did the Soviet Union admit privately that there had been some sort of accident at Chernobyl. By noon, on Monday, 42% of Forsmark's area residents had heard about the events at the plant. By the same evening, 66% had been informed. In Pripyat, the city adjacent to Chernobyl, as we've just heard so compellingly by Carla, so in Pripyat, preparations were underway for May Day celebrations, so no word would be uttered publicly as to the extent of the radiological disaster that lurked directly within their midst for more than 19 days. In the crucial period immediately following the explosion at Reactor Unit 4, silence on the part of the Soviet state would prove fatal, as emergency measures such as the distribution of iodine tablets, which can absorb and neutralize radioactive isotopes, were not implemented. The material witness that would first come to testify publicly to the accident at Chernobyl was not to be found in the vicinity of the reactor, but on the soles of an engineer's shoes located more than 1,100 kilometers away from the scene of the crime. Today, any database search engine will return the nuclear accident at Chernobyl when the date April 26, 1986 is input into its search parameters, whereas a microfiche review of Soviet and international newspapers from the same period reveals a time lag of 19 days before the event registered publicly in print that a major nuclear accident had taken place. Although an orbiting American satellite took nighttime images of the reactor explosion, and scientists and meteorologists outside of the Soviet Union recorded extraordinarily high levels of radioactivity within days of the meltdown, this information was not publicly acknowledged as pertaining to Chernobyl for almost 3 weeks, since Mikhail Gorbachev and the Central Committee largely withheld news of the disaster. And these are just some of the microfiche images that I took actually at the library at UWO, in fact, a number of years ago. On April 29th, in response to rapidly growing rumors circulating outside of the Soviet Union that something had happened at Chernobyl, did Gorbachev deign to place a series of discreet notifications with five Soviet news agencies, indicating that a minor incident had occurred at Chernobyl. And I quote, "An accident occurred at the nuclear power plant in Chernobyl. One of the reactors had been damaged. Measures have been taken. A governmental commission is inquiring," end quote. In reality, the accident at Chernobyl was massive, releasing higher levels of radioactive contaminants into the environment than any preceding radiological event, whether the detonation of 2 atomic bombs over Hiroshima and Nagasaki in 1945, the fallout from atmospheric nuclear weapons testing in the years between 1952 and 63, the explosion at Mayak, also in the former Soviet Union, or the fallout from atmospheric or the partial reactor core meltdown at 3 Mile Island in 1979. By severely underplaying the gravity of the situation, tragically delaying reports that a substantial nuclear explosion had taken place, and downplaying the potential for contamination, a tragedy of far greater consequences ensued. For those working at the Chernobyl nuclear power plant or living in the adjacent city of Pripyat, this time lag would prove fatal, as malignant cells metastasized, seeding their defects throughout the zone, and eventually airlifting their malevolence across the borders of the Ukraine into Belarus and Europe. Despite this interval in public disclosure, evidence of an immense release of airborne radioactive contaminants was already being carried from the USSR across Belarus and Poland to settle throughout northern Sweden, where it was absorbed into surface water, groundwater, biota, and soil. Cesium-137 is one of the most challenging short to medium-term fission products because it is so highly soluble in water and thus able to move and spread easily in natural environments. A dangerous arrangement of nuclear matter composed of 82 neutrons and 55 protons would disclose a unique radiological identifier known as cesium-137 that could be traced directly back to its source in the Ukraine. Contrary to the homegrown chemistry of Forsmark's radioactive outputs, Chernobyl had unleashed billions of becquerels or units of radioactive material in the form of strontium, plutonium, iodine, and in particular cesium-137, creating a trail of atmospheric evidence. So even invisible particles carried aloft by the wind or adrift on the ocean's currents can be made to speak and eventually testify to the disasters that spawned them, the fact of their unique anthropogenic origins distinguishing them from other naturally occurring radiological elements. Hydrology, my last example. On February 19th, 2015, water samples taken off the coast of Ucluelet, sorry, my pronunciation's terrible. On February 19th, 2015, water samples taken off the coast of Ucluelet, a historically First Nations community located on Vancouver Island, revealed for the first time ever, trace evidence of the radioactive isotope cesium-134 as well as cesium-137. The levels detected were extremely low and far less concentrated than the dose of radiation we receive annually from exposure to natural background radiation, or indeed the everyday levels of radiation we encounter when using a mobile phone, traveling by plane, smoking, or undergoing routine dental x-rays. Yet the scientists at Woods Hole Oceanographic Institution in the US, who tested the water samples from Ucluelet, said they could only come from one source, the nuclear accident at Fukushima, which had taken place 4 years previously in March 2011, when a tsunami and earthquake colluded to wreak havoc on the eastern shores of Honshu Island. While Chernobyl's fallout would eventually spread across extensive tracts of arable land in Europe, Fukushima's contamination seems to have traveled further still, crossing some 7,600 kilometers through the vast microbial channels of the Pacific to reach the western shores of British Columbia 4 years later. And just a short clip from the news.
Traces of radioactivity from the nuclear accident in Japan 4 years ago have washed up on Canada's coastline. It's the first time they've detected materials from the accident in North America, but they say the amounts don't pose a threat to living creatures. Scientists at the Woods Hole Oceanographic Institution tested samples of seawater collected in Ucluelet, British Columbia, 2 months ago. They found traces of cesium-134. They say the levels were 1.4 becquerels per cubic meter, well below the internationally set level at which human and marine life can be affected. Cesium-134 is produced only by human activity. The scientists say the Fukushima Daiichi nuclear plant has been the only place where the material has been released in recent years. The team has been collecting samples from along the North American coast for more than a year. They'd previously detected radioactive materials offshore, but not along any beaches. Researchers expect to find detectable levels of cesium-134 in other areas in the coming months, and they say they will keep monitoring the situation.
So as I said, both cesium-134, which was more dominant, and cesium-137 were detected in the water samples that were gathered largely by processes of citizen science, in fact. So community members that would then send their water samples onwards to Woods Hole. So as we've heard previously at the beginning of this talk, cesium-137 did in fact make its first appearance in the early solar system through processes of natural nuclear fission, as that which occurred at Oklo. More than 1.7 billion years would pass before it reappeared on planet Earth in any detectable amount, this time on December 2nd, 1942, as a result of as I said, of the chain reaction produced by the first ever human-made nuclear reactor, the Chicago Pile, built under the supervision of Fermi. But in the following decades, humanity began to significantly change the global radiation environment by testing nuclear weapons in the atmosphere. By the early 60s, there was no place on Earth where the signature of atmospheric nuclear testing could not be found in soil, water, and even polar ice. According to disclosures made by TEPCO, the company that owns and operates 17 of Japan's 54 nuclear power plants, including the Fukushima Daiichi plant, at least 2 trillion becquerels were released into the Pacific Ocean between August 2013 and May 2014 alone. Today, irradiated debris and contaminants from the damaged plant are still being discharged into the coastal waters off Japan's eastern shore. In deliberate efforts to diffuse and slow down the rate at which radioactivity builds up ever more lethal concentrations in the groundwater around the plant, TEPCO continues a program of intermittent release of radioactive material into the ocean. Water samples taken off the coast of Japan during the immediate aftermath of the accident registered the presence of extraordinarily high levels of radioactive isotopes, 50 million becquerels per cubic meter. By the time the ocean currents had carried the contaminants across the Pacific to the coast of British Columbia, hydrological dispersion had reduced the concentrations to 1.4 becquerels per cubic meter of cesium and 5.8 becquerels per cubic meter of cesium-137. According to, this is a quote, according to Canada's Department of Fisheries and Oceans, the Pacific Oceans typically contain cesium-137 levels of only about 1 becquerel per cubic meter, making the levels on the BC coast nearly 6 times higher. Spatial and temporal dispersion doesn't diminish responsibility, nor indeed hide the culprit from the crime. We really know very little about the long-term cumulative health effects of radiation exposure over millennia. Just as July 16, 1945, irrevocably altered the planet's baseline radiation, as naturally occurring cosmic and terrestrial radiation was supplemented by newly created forms of anthropogenic radioactive isotopes, Scientists at Woods Hole Oceanographic Institution remain cautious and don't diminish the significance of the measurements taken off British Columbia's coasts. And I quote, "Radioactivity can be dangerous, and we should be carefully monitoring the oceans after what is certainly the largest accidental release of radioactive contaminants to the oceans in history." End quote. In Nootka, which is the First Nations language spoken in the area of Iqaluit, in Nootka, Iqaluit translates as people of the safe harbor. And now, let me see what I have. I think I just want to wrap up here and make a few kind of general kind of comments, and maybe they would be the basis of discussion that we could have. So in sketching out the geological, meteorological, and hydrological appearance of nuclear evidence secreted within the molecular arrangement of matter, I wish to reestablish a version of Locard's exchange principle. And Edmund Locard was the sort of pioneer or father of what is considered modern forensic science. And he established the Locard exchange principle, namely that every contact leaves a trace. So I wish to reestablish a version of this principle, that every contact leaves a trace, regardless of the scale and duration of nuclear events that suggest cause and effect are incontrovertibly pulled apart. Within climate justice work, the problem of proving direct causality between polluters and damaged ecosystems or health-related effects has itself proved a useful legal loophole to avoid paying out claims for compensatory damages or ceasing to engage in harmful activities. When the legal demand for such demonstrable proofs that one must be able to establish the incontrovertible relationship between cause and effect or direct evidence, when this juridical requirement is recast as a political demand, justice will always be disabled, even as many work hard to reestablish such causal relations. The condition of determinacy, as Ian Bohl also suggested yesterday, has allowed global climate change actors, such as oil and gas, to operate with virtual impunity. Inasmuch as charges of criminal liability must meet the condition of direct causality in order to achieve success in litigation, I would argue that the political, too, must take on the project of causality as one of its primary tasks, namely to reconnect the links that large-scale planetary phenomena has seemingly torn asunder. Certainly, this is already part of contemporary activist strategies, but the slow violence that often characterizes these kinds of events or underpins the longue durée of their evolution is less amenable to media mobilization and humanitarian intervention than the kinetic violence of military conflict and war. The struggle for justice in the post-Soviet nuclear environment offers a case in point, as long-term health risks and ongoing fatalities directly attributable to Chernobyl and its radiological aftermath are still being hotly contested. It is the very lack of direct causal connections between the event and the slow release and accretion of its harmful effects that renders its political stakes all the more urgent. But the nuclear isn't exactly like so many other contemporary threats, which operate according to complex, nonlinear modes of causation, such as global pandemics, environmental hazards, counterinsurgency, and war. The kind of terror that Brian Masumi describes in his latest book, Ontopower, as an ultimately untraceable, nonlinear microflow that self-amplified and spread across the planet. Strangely enough, even highly dispersed evidence of nuclear events is often directly traceable back to its source, as is the case with the appearance of cesium-137 in Forsmark and in British Columbia. The unique chemical properties and behavior, that is to say decay rates, of artificially produced radioactive isotopes leave trace evidence of events behind them, even when this evidence is radically delocalized. Of course, the fact of their evidential appearance doesn't translate into a convincing narrative of responsibility without considerable work to corroborate the particular risks related to levels of exposure and concentration of dosage. Now, I'm going to stop here, but I want to think with you and through these brief examples about questions of material evidence, the changing scales of perception and detection, the deep time of anthropogenic violence, and possible forms of action or intervention based upon an ethics not just of visibility, but of duration. What I'm calling, in effect, a politics of the remainder. What new kinds of practices and modes of political engagement must we would develop when evidence for events falls entirely outside the register of human perception and increasingly requires the intercession of a techno-scientific apparatus to render it sufficiently legible such that we can interrogate its truth claims and make or recalibrate our demands for accountability and perhaps even justice. This is something we're going to talk about tomorrow in the workshop with James and myself, because I would also include things like algorithmic decision-making in this question about the events that are happening entirely, if you will, beyond the level, beyond the sort of scales of human perception. So yes, so what kinds of new practices and modes of political engagement must we develop? This, I feel, will require much greater participation in the epistemological frameworks that currently organize and manage these techno-scientific assemblages, and that may very well be a formidable challenge for us all. And I think I'm going to leave it there, John. Thanks.
Thank you, Susan. That was really breathtaking. And I think as I'm trying to take up the last provocation of this kind of work and the politics that you then started to think through in relation to it, I'm curious about the figure that I kept thinking about as you were speaking from beginning to end, and that's the figure of the detective and the intellectual as the detective. The language you used was so rich in terms of scenes of the crime, traces, evidence, cues, and so forth. That's the kind of stuff I know from detective narratives. And there's two basic subgenres in the detective narrative. One is the hard-boiled detective, where the detective is implicated in the crime. Right. And the other is the more neutral Sherlock Holmes type of detective, where they're looking at it from a distance and they have a little more objectivity. So I'm just curious, in terms of your own method and the politics that you're trying to draw out here, do you see this work in the more the hard-boiled mode or the more neutral, distance, objective mode?
Should I use this?
Use that, yeah.
Okay.
I can put it back on.
Oh, okay. I just hold it, because you might want to use it.
No.
Okay.
I'll yell.
That's it's a wonderful question and observation, and I think in some way it might actually also. Sorry, now I'm struggling. In an interesting way, it might also distinguish perhaps my approach, perhaps somewhat to that of Eyal. I mean, Eyal's written a very kind of polemic article for radical philosophy that came out early on when we started the project, and it was only the criminal can solve the crime, and he was really looking at the work of Mark Alaska, who was a munitions expert, and this was in the case of the Israeli-Palestinian conflict. But in terms of my own work, I think I would actually follow the model of Sherlock Holmes, and when because there is also this interesting moment when Sherlock, I think it's with the first novel, where there's a soldier returns and Sherlock Holmes makes this observation, and he says, "Sir, I presume you've come back from Afghanistan." And it was this, and it was based on his posture, etc. But also, I've lost my train of thought. But I suppose yes, of course, there's a kind of language of the detective of forensic science, and I'm drawn to. I can see that sort of resonance. But the one thing actually I would say that is maybe slightly tangential, but I think is very important to articulate, and I think it's a current condition in which we're living, in which investigative work increasingly is being outsourced by our states to citizen science, to investigative journalism. I work a lot with the Bureau of Investigative Journalism in the UK, and we can see the ways in which the responsibility of states to investigate contemporary political violence is largely becoming, as I said, outsourced to citizens. I mean, if we look at Iraq, Syria, the enormous kind of wealth of information that's being generated by activists on the ground, which is formidable and necessary, but we also see a certain kind of relinquishment of what I would say are the kind of the moral responsibility of the state to actually investigate. And so investigation, in effect, is I think, a very important kind of political term for me, precisely, and I think that's in some way at the heart of my kind of research as to how do we begin to investigate a contemporary political condition. And so my strategy has always been to go through, it's a very kind of Benjaminian sort of approach, to look at this kind of detail in the sort of smallest crystal and to try and unfold the kind of event. And in some way that is the kind of like, that's the sort of modus operandi of Sherlock Holmes as well, right? Was putting together all of these kind of micro kind of details where we might actually have some sort of insight provisionally into some sort of event. But it's a beautifully articulated question.
I think you illustrate and articulate very well particularly the stretching of the scale from just reacting to the immediate event to recording this very long history of evidence and gathering something that happens at a different scale. And while there's a whole bunch of problems with doing that through kind of extensions through technology and having to understand all that process and so on and so forth, that you've demonstrated how that can be done very well. But at some point, that scale then gets compressed as soon as it is submitted as evidence. That it then, you can gather and assemble this information in this kind of way, but at some point it still has to re-enter this short term of courts or of the judgment or the process at which that evidence is actually considered and is then judged upon, or some decision is handed down, or whatever that is. Is there any way of taking these long-term ways of thinking and these technical evidence-gathering things and all these kind of forensic processes, but applying them to like the next stage as well? When like, what happens when this stuff goes to court, or where does it go, and does it survive that compression? Does that make sense?
Yeah, I mean, I would actually say my experience in terms of the juridical is largely, my personal experience in that I would rely on in answering this question would be the sort of multi-year research I've done with the material archives of the International Criminal Tribunal for the former Yugoslavia, the ICTY, and I've looked at the ways in different kinds of evidence, questions around an edit in a video with the destruction of the Mostar Bridge became a kind of important kind of point in the legal proceeding that required the intercession of scientific expertise, of forensic video analysis to ascertain what was the significance of the kind of edit. What information does an edit actually cut out of the picture? So I think there are in fact many, many kind of instances where the kind of micro details are actually more significant than what's happening in the field of representation, because in those details, that is where doubt lurks in terms of the veracity of the event. So certainly with the work that forensic architecture does, we have to make very elaborate kinds of presentations on our methodology and how metadata is used, how time coding between, I'm sure Eyal will talk about this, but thousands of different sort of images captured by smartphone, all of which had kind of date and time sort of mismatch, how all of that how those materials are reorganized, and then how our own decisions, we have to account for the decisions we make, but the decisions about information that is not occurring within the field of representation. So I think there's actually, increasingly, we're going to move into a juridical environment where the sort of, what you're identifying as a scale that's not the kind of macro scale, but the micro scale of information assemblage is actually going to be ever more kind of crucial, and it'll be and this is what I argue in the work that I do, is that the place of politics resides within the kind of the micropolitics of processing, not in the kind of field of pictorial representation, but the politics of the event are located at every moment where information is translated from one file format into another, where decisions about what kinds of information is selected as significant, what is retained, what is discarded, what are different compression codecs doing to the kind of integrity of information. All of those are the kind of junctures where the political is disclosed, and we also see that same disclosure troubling juridical processes as in fact. Yeah.
Thank you so much for that presentation. It was fabulous. So when you say we need to kind of focus on this evidence outside of human perception, this evidence that requires some kind of scientific or technoscience approach to it, I'm wondering if you could speak to that in comparison with, I read your piece, Can the Sun Lie?, which I thought was a very nice small piece that kind of speaks to the significance of experience as well. And I wonder if you could just speak to the difference between evidence in science and evidence as experiential.
Yes, thank you for that question. What I was trying to say towards the end of the talk was that not that we have to be, I think it's what I was raising that question because I was thinking about it a lot in relationship to some of the writing I've done on looking at legal accountability for the use of algorithmic decision making, especially in the ways in which the United States is charting its kind of roadmap up to entirely kind of fully automated and robotic kind of systems, and sort of thinking it, but we can also see that within high frequency trading, etc. There are no courts that can deal with that as of yet are tasked with dealing with financial crimes, for example. So it's a kind of question for me in terms of, and James raised that yesterday as well in terms of kind of big data. So a field in which, so it's like, how would we actually, when we see that image of the black stack, for example, what's a mode of resistance that actually, the black stack is a kind, it is not the thing itself, it's a kind of mirage that accounts for a set of kind of conditions, if you will, but it isn't, now I guess we could technically cut the kind of transatlantic cable as a kind of act of political resistance. But anyway, that's the way I'm trying to ask. It's not like, I don't want to invoke science as the kind of palliative, but it's trying to understand what kind of resources and knowledges we would have to develop in order to intervene when we're confronted with decision-making happening entirely beyond the realm of, say, human perception and certainly visual kind of perception. So that's the sort of question I ask myself. In terms of Can the Sun Lie, another thing that's very important would be the regime of witnessing and who has the authority to speak on behalf of a particular kind of condition. And even when someone is speaking the language of science, as Zachary Kunuk in his film Indigenous Knowledge and Climate Change, which that essay draws on, looks at this moment in the Canadian Arctic where there's an observation being made on the part of Inuit that the sun is slowly setting further west, I think 19 kilometers further west. And when they go to Copenhagen Climate Change Conference and suggest the proposition that the Earth might have tilted on its axis, that's the language of physics that they're using. They're not using a kind of invoking a native cosmology to account for this observation in their kind of transforming kind of world. And so we see a clear example that raises the question on who has the legitimacy to speak on behalf of their kind of condition, even when the language that is being mobilized is in fact a language that we would associate with the sort of quasi-objectivity of science, if you will. So it's an extremely kind of important point that you've raised. And it's about troubling those the kinds of the epistemological frameworks and institutional protocols that allow certain subjects to become the kind of spokesperson, or to have the kind of singular kind of legitimacy to speak on behalf of a certain condition. And within the juridical environment, that's extremely kind of prominent. And I've had a lot of very antagonistic relationship discussions with ICTY prosecutors who don't appreciate my kind of reflection on their kind of practice, because that's a discipline that's, criminal law is very kind of in some way internally policed oftentimes by practitioners, and isn't that amenable to an artist actually looking at their practices and commenting on it and making them public in some fashion.
We have time for two more. Well, and Karen, you haven't spoken. So, Peter, you go ahead and we'll work this out. Peter,
Okay, all right. Is this on?
brief answers.
Sorry, okay.
No. Just,
Yes,
I'll be
yeah.
And
Okay.
Eric up at the back had his hand.
So my answer is
And you have
yes.
your hand up.
Yeah.
And you have your. Anyway, Peter, please go ahead.
Okay, so two things, right? First, I just wanted to comment on the. See, it's not on. Is it? Yeah. On the methodological thing about detectives, and I think that's really right. But it's not just Conan Doyle. It's like it's pure kind of Peirce, as in Charles Saunders. Peirce. This is abduction, right? This is really an exercise in abduction, in the sense that you're proceeding here by or via the surprising fact. Right? The surprising fact. So you just wanted to throw that in. It's just like this is a kind of a very skillful exercise in, I think, that kind of procedure, which isn't inductive exactly, and it's certainly not deductive. It is abductive. Anyway, we can talk more about that at the other end. The thing I was interested in is these enclos reactors, right, and the way that they get taken up by the nuclear industry is really very interesting. They come to be called not so much natural reactors as natural analogs, and so spawns this whole kind of subfield of natural analog studies, in which these reactors then start to tell stories about, well, for the Americans, for instance, about the overall stability of the migration of radionuclides in the wake of criticality. And so they come to tell stories about, well, look, here, we only have this much creep over this many billions of years. So clearly our kind of repository designs can absorb sort of discourses of security from these natural analogs. And it's not really a question as much as it is an observation about the kind of openness that these things have to appropriation and repurposing to support kind of other things that we might not, in the first instance at least, be thinking.
No, I mean, that's not part of the sort of story I told, which is interest in like geological repositories, et cetera, looking at the ways in which, there's been a stabilization of a set of nuclear kind of fissions over the kind of, obviously the longue durée of the Earth, and so therefore it becomes a kind of justification rather than a kind of cautionary kind of sort of message. So, and I completely kind of agree. In some way, it's like that's always my kind of uneasiness when and in some way I'd say this is probably not. I'll be short, but it's like my uneasiness with someone like Georges Bataille, where we try to look at kind of biological systems as analogs for other kind of processes that are happening, but that's a bit tangential, I realize, as a response. But yes, I completely agree. And part of the ways in which these have been, the uptake of the natural nuclear reactors has been to say, look, I mean, if nature is able of stabilizing these kind of emission products, then what's the big kind of worry? Absolutely.
I've made a decision how this will work. We'll hear from Karen. After all, she began as a nuclear physicist and absolutely has to speak, as well as be a cultural theorist. And then from front to back, we'll hear from Derek at the end, and then we'll break for lunch until 2:15. Karen, please.
Thank you very much for that really wonderful talk. And now that I've been acknowledged as a scientific authority, I want to mobilize science in order to undercut science's authority, or maybe to recut it and reslice it in different kinds of ways. So I want to applaud your attention to detail. I think it's so crucial in terms of these kinds of intervention. And I want to say that I think for too long we've been lying to ourselves about something that has to do with quantum physics. And so I want to call that lie by starting and talking about the way in which the legal system and other ways in which we normally talk about evidence and relations of cause and effect are built on Newtonian physics, strict determinism. And quantum physics calls that on the carpet and says that isn't the way in which causality works. And then we tell ourselves a story about the way in which quantum physics only applies to the micro level and not to the macro level, as if somehow there's a line in the sand in terms of the physics. But also, more to the point, is that quantum physics calls into question the whole notion of scale. Scale is not given. The whole notion of entanglement redoes scales and enfolds scales into one another and so on and so forth. And so instead, I love this way you talk about every contact leaves a trace. I think that's exactly right. That's something I want to talk about this afternoon as well. And the thing is that I want to evoke a notion that gets used in lots of different ways. And I want to, in terms of my own interest in it, the word is entanglement, has a very specific notion to physicists. And it has to do with a particular structure of causal relations and what they look like. And so taking very seriously this idea of tracing entanglements and the work of citizen scientists and the work of indigenous peoples and who gets to speak and so on and so forth has to be a part of these tracing of entanglements. And I wish we could think together of a way to instrumentalize some kind of way of shifting the legal discourse and the legal criteria around this away from Newton.
No, thank you for that. And it's, you don't know, but when I embarked on my PhD, I was at that moment, I was calling it entangled matter. And then in the midst of my PhD, this massive book was published, which was your book. And I was actually in my kind of, in very unformed way at that moment, trying to use entanglement not as a metaphor, but really trying to talk about the ontological inseparability of all matter. And that was really the kind of driving force of my PhD inquiry, was to insist on entanglement as a kind of material condition rather than a kind of metaphoric descriptor. I never really managed to make that move between the micro scale and the ramping up to the macro was my challenge, and I never felt I was entirely successful in sort of doing that. And it's like heartening to hear you speak and to sort of insist on that as an actual, as a possibility, and that's where the work needs to happen.
Yeah. It's not about analogs, just to reflect back on the other question. It's not about analogies between what's happening at the so-called human scale and what's happening at the so-called micro scale. So the whole way in which we think about space, time, and matter gets rethought through quantum physics. And I think it's the radical potential there for disruption of certain kinds of ways of enlightenment thinking could be really importantly mobilized.
Yes, absolutely. And in particular, like all of the ways in which quantum weirdness defies all of the sort of logic, the inheritance of kind of logic that we're, I think it's precisely, it's kind of, it's radical kind of, the ways in which it can address kind of radical states of matter, like the quantum eraser, all of these ways that trouble all of the kinds of epistemological kind of frameworks that we've developed. And it's, I think your work is absolutely inspiring, precisely for putting that kind of in play. And I need to work also with those materials sort of definitely further.
Derek in the gods.
Appropriately.
God.
This takes us back to the detectives, I'm afraid, because I think that serious crime fiction is much richer than Eric suggested. And it seems to me that the model which comes closest to what you're describing is the police procedural. Because what lies behind those three case studies that you offered are clearly teams of scientists and investigators who, in a sense, reinstate the logic, the operating principles of a techno-scientific process. I would go one step further too and say that one of the cardinal principles that Lacard put forward was surely not simply that every contact leaves a trace, but it's also about dispersal. It's precisely about a perpetrator coming in and leaving something behind, and then when he or she exits, taking something with them. So the logic of dispersal in space and time that you identify seems to me to be absolutely focal to your project. But what I find so compelling about what you've done and about mobilizing, so to speak, these different procedural investigations and then turning them to forensic account is that it doesn't simply call into question our conventional understanding of the techno-scientific process. It doesn't even simply call into question what we think of as evidence, because we know that the sort of evidence that is admitted into court proceedings is itself highly unstable, which is why there's so much attention paid to the chain of custody, and why there's so much controversy even now about something which most people think of as stable as a fingerprint or a DNA marker, so that the objectness starts to change. But it seems to me that what you actually do and what you're demonstrating is a new politics of objectivity, where what it is to conceive of that object in all its multiple forms and all the different registers through which it appears is precisely what enables you to conduct this kind of forensic investigation and to bring it to the attention of a public. So thank you enormously. It's not a question. I'm just lost in admiration. Thank you.
Yeah, great.
We both think that's a good ending.